Hello to all my friends. Today we'll discuss how actually regression works. So in my previous video I have explained you what is regression, how does it help find the relationship between different variables, independent and dependent variables, and today we'll talk about how actually this works. So I'll explain in a very simple manner that what is the fundamental principle behind regression. Imagine that there are certain data points lying here and there in the space. These are the data points or the observations, and there's one ruler, a scale. So you can imagine it's a scale, a ruler. What regression does is it rotates this scale in the space so as to find the position where maximum number of the dots lie close to this straight line of the scale. You see this straight line of the scale? Maximum points lying close to this straight line. So this is the principle behind regression equation, which is finding out predicted value of y, which is the dependent variable, using this equation, a, which is the intercept, as I explained in my previous video also, plus b, which is the slope, multiplied by the value of dependent variable, that is x. So this equation is regression equation known as ordinary least squares. It works on the principle of ordinary least squares, OLS. OLS. Now let us find out what is this OLS. What do we mean by ordinary least squares? What is this least squares? So that we get the line of best fit. We call it line of best fit. What do we mean by this? Line of best fit means where the residuals error are minimum. There is minimum scope of error between the predicted and actual value. The difference is the least. So as I told you, residual are the errors which are calculated from the available sample data through the formula, which is actual value or the observed value minus predicted value. So this line of best fit tries to minimize the errors, minimize the residuals, so that the prediction becomes more accurate. So now let us see through an example and try to understand how this works through manual calculation of slope, intercept and regression equation. Stay tuned and keep learning. So the x, which is the independent variable, that is study hours, and y, which is the dependent variable, we call it dv, exam score. So we have some data with us, the sample data of 3 students. These are the students A, B and C. So if we say that study hours being put in by student A is 1 hour, by B is 2 hours and C studies for 3 hours, their exam score is 2, 3 and 5. So I'm just taking simple one digit hypothetical values so that our calculations become easy and we are easy to find out how this actually works. How do we get onto the line of best fit? How do we get the line of best fit through regression equation? So now you understood this is the sample data which we have. We need to find out the line of best fit, and according to that line of best fit we are going to predict the values using this equation a plus b into x. This x is independent variable, y is the predicted value of dependent variable, that is exam score, a is the intercept, b is the slope. As I told in my previous video also, intercept means the value of y when x is 0. The value of y when x is 0. Slope means how much change is there in the dependent variable, whether it increases or decreases, whatever is the change on increasing 1 unit of x, that is independent variable, study hours in our case. So now we can go ahead with the calculations. How to do them? Let us start with step 1, which is calculating the means. Calculation of means is the first step. How do we do this? We have to find the means of independent and dependent variable. Independent variable and dependent variable. Say for independent, the mean is 1 plus 2 plus 3 divided by 3 is equal to 2. For dependent variable, the mean comes out to be 2 plus 3 plus 5. Remember, these are the marks secured by 3 students. Divide by 3, we get 3.33. So we got the mean of independent and dependent variable. Next step is we calculate the slope. Slope, which is b, required to be entered into the regression equation. So the formula for calculating slope according to the calculus, and how does software calculate it, I am going to show you that formula. The formula is summation of x minus x bar, y minus y bar over summation of x minus x square. So now first we are going to calculate the numerator and then we are going to calculate this denominator to find out the slope. So for the numerator, we know the values which we have of x and y, 1, 2, 3, y is 2, 3, 5. Next is x minus x bar, then y minus y bar. You see, these are the same which we have seen over here. These numerator we are trying to calculate, and then the product we are going to find. So here we have x minus x bar, x minus x bar. So the mean was, you see here, the mean is 2 x bar, right? So 1 minus 2 is minus 1, then 2 minus 2 is 0, 3 minus 2 is 1, right? Similarly, y minus y bar, y is 2, y bar, you see, y mean is 3.33. So we get the value minus 1.33 minus 0.33, 1.67, right? Then finding out the product of these two, x minus x bar and y minus y bar, we get 1.33. So the minus sign goes away when we multiply. Here we get 0 and here we get 1.67. So this is what we get. Now we sum up the product and what we get over here? We get 3. 1.33 plus 1.67 is 3. Now this is the numerator. Next we will find this denominator, x minus x square, summation, right? Summation of x minus x square. This is the denominator. How to calculate this? You see x minus x bar and then square of x minus x bar. The value of x is 1, 2, 3 as we know. X minus x bar minus 1, 0, 1. Then the square of this value 1, 0 and 1. Adding all of them we get 2. So this is the denominator, right? Denominator. Now when you see here numerator and the denominator, put the values in this formula to get the slope. What do we get? We get 3, that was the numerator, and 2, which was the denominator. We get slope is 1.5, right? The value of slope is 1.5. So we have found out what is the value of B. Now we need to find out the intercept, which is A in our regression equation. For finding out the intercept, the formula is y bar minus b into x bar. Here you enter the value of y bar, which we found out, which is 3.33, minus slope, which we found out just now, b, into the value of x bar. So the value of x bar, which we initially found the mean of x, that is independent variable, was 2, right? So this comes out to be 0.33. If you subtract 3 from 3.33, you get 0.33, right? So this is the intercept. Now we have got the intercept to be put in regression equation. To find out the predicted values, why we use that equation? To find out the predicted values. We are going to predict the values, the marks secured by students depending on the study hours which they put. Actual data we already have, but we are going to know the predicted values as well, so that we can compare the prediction with the actual values and find out the residual errors. And as I told you, the line of best fit tries to minimize the residuals, right? A is the intercept, which is 0.33 plus 1.5, which is the slope, and x. Now for the first, if you remember, x and y was, x was 1, 2, 3 hours and y was 2, 3 and 5. These were the marks, right? These are the marks and these are the study hours. So this was our sample data. So putting the first value of x, that is 1, what do you get? You get 1.83. This is the predicted value of y when x value is 1, right? When x value is 1, the predicted value of y is 1.83, though the actual value is 2. You see here, this is the predicted value through regression equation, and this 2 is the actual observed value which we have gotten in our sample data. This is the actual, this is the predicted. Similarly, we take out for 2 and 3, 2 hours and 3 hours, just replacing this 1 with 2 and 3. So you get the values. Now Once you have that, you can draw a table like this. You see 1, 2, 3. Actual value of y, which is observed value, is 2, 3, 5. Predicted value is 1.83, 3.33 and 4.83. Then residual is actual minus predicted. What do we get? We get 0.17 minus 0.33, 0.17. Now we have to square up this error or the residual. We denote it by e square. So when we square this thing up, what do we get? We get 0.029, 0.117, 0.029. This is what we get. Why do we square it? Because if we don't square it, we get the negative values. We will not be able to get the positive values, and the values will cancel out with each other. We see the total of these errors. The total becomes 0.168. This is the total, right? So this value, which is 0.168, what does it denote? It denotes the smallest possible total squared error for any straight line fitted to these points, right? This is why least squares regression line is called the best fit line. So now you have understood why it is known as the best fit line. I hope I have made myself quite clear, and now you have understood the concept behind regression and how does this equation of prediction works in case of regression analysis. I hope you liked the video and you will definitely share it with your friends and faculty colleagues. See you next time with some more interesting and informative content which will definitely help you in writing good research articles, good dissertation, and of course, if you are a PhD scholar, would help you with statistics to make your work, make your thesis quite impressive to the supervisors and the examiners. Thanks a lot.